This diagram provides a clear step-by-step explanation of Kafka's behavior during a network partition and how it determines which brokers continue to serve as leaders. Kafka is designed for fault tolerance and high availability, but when network failures occur, it must re-elect leaders while maintaining data consistency and availability. 1. Kafka cluster before partition. At the start, Kafka operates normally with Zookeeper, active controller, managing cluster metadata and leader election. Broker 1 is acting as the leader for a partition. Broker 2 is a follower, replicating data from Broker 1. Everything is working fine. Kafka is processing messages without issues. 2. Network partition occurs. Suddenly, a network failure isolates a subset of brokers, creating two separate segments. 1. Partition side, connected to Zookeeper. Brokers that still have access to Zookeeper remain operational. If a broker on this side was the leader, it continues as the leader. Kafka remains available for producers and consumers connected to this segment. 2. Isolated side, disconnected from Zookeeper. Brokers lose connectivity to Zookeeper, meaning they can't communicate with the active controller. These brokers step down as leaders and stop serving client requests. They remain in standby mode as followers, waiting to reconnect. At this stage, the isolated brokers are effectively non-functional. 3. Recovery and reconnection. Once the network heals, the previously isolated brokers reconnect to Zookeeper. They resynchronize data from existing leaders. If necessary, Kafka re-elects leaders based on the latest in-sync replicas, ISR. The cluster returns to normal, ensuring data consistency. Kafka ensures that leadership is re-established correctly before processing resumes. Key takeaways. Brokers connected to